All right, in this video, we're going to take a look at determining and interpreting the coefficient of determination. So in previous videos, we've looked at how to calculate the value of our linear correlation coefficient, R, and a value R squared, which we've seen in some of the examples in the both Desmos and Python program that we've used. The value R squared is called the coefficient of determination. So we hop back to our linear regression with Desmos. It gives us R squared, which is just taking this value of R and squaring it. So 0.9588 when we square it is about 0.9194. And with our Python printout as well, it gives us a value of R squared, the same value of R squared. And that's going to tell us what percentage of the variability in our response variable, or our y values, what percentage of that variability is due to the linear relationship of x and y. So the rest that is not accounted for, so let's say there's 75% is due to the linear relationship between x and y. The other 25% may be due to such things as lurking variables. So again, a lurking variable is a variable that is not considered but does have an influence on the response variables. So it would influence the y values when we didn't take it into consideration. And for r squared, since r is between -1 and 1, when we square a number that's between -1 and 1, we're going to get results that are between 0 and +1. So remember, any negative number when we square it becomes positive. So squaring any number between -1 and +1 is going to give us a value that is between 0 and 1. So all of the values of r squared are going to be between 0 and 1. So because we're looking at values that are between 0 and 1, we can also, again, think of r squared as a percentage if we just convert the decimal to a percentage. So what exactly does it do? I mean, what's the purpose of it all? Why even bother with having an r squared if we have r for our linear correlation coefficient, we have our regression equation, our linear regression equation, y equals mx plus b. What's the purpose of it all? Well, without our regression equation, the best predictor for response variables, our y values, would be the mean of the y values. So if we didn't create that regression equation like we looked at in the last video, then our best predictor that we can use for our y values is going to be the mean of our y coordinates in our data set. So again, the least squares regression line was the best predictor for the data set. And if we didn't have that, the best we could do is let's just take the average of the y coordinates. So the value of r squared, another interpretation of it, it represents how much of a decrease in the prediction error we get, or the residuals, from using our regression equation rather than using the mean. So it'll also show us that we have a decrease by whatever that percentage is in the prediction error or the residual that we're going to get from using our regression equation rather than using the mean of our y coordinates. Now, if r squared is close to 0, then we're not really going to have much of a percent decrease from using our prediction equation versus just using the mean of our y coordinates. So our linear regression equation is not going to be a very good predictor. And in that case, just go ahead and use the mean of the y values as the linear predictor equation. So again, if your data set kind of looks like a cloud, or somebody just sneezed on it, doesn't really have a pattern to it, then you're no better using the mean of the y coordinates as a predicting equation compared to whatever your linear regression equation would be. So example 4, determine and interpret the value of r squared given the paw width in inches and dog's weight in pounds below. So here we have various paw widths in inches from what appears to be various breeds, and the weight in pounds of the dogs as well. So here's a scatter plot. And if we take a look at the value of r squared from this data set, if we enter it into either Desmos or Python or whatever program you happen to be using, we get an r squared value of about 0.8049, or about 80.5%. So looking at our prediction error, if we use our equation that we would get, our linear correlation, or not our linear correlation, our linear regression equation rather, for this data set, then that's going to reduce the prediction error by about 80.5% than if we just use the mean of these y coordinates as our predicting equation. So again, r squared is about prediction and how much better our prediction is using our equation that we came up with in our last video versus just finding the mean of these y values and using that as our equation. So a significant reduction in the error that we would have for our prediction. So our residuals would be a lot less if we used our regression equation versus the mean of the dog weights. So since we only get values of r for linear regression, we're not going to calculate the linear correlation coefficient for a data set that does not appear linear. So for instance, let's say this data set here, we have it going up and then it comes back down. This would not be considered a linear data set. So if we tried to find a regression equation for this, and there are entire statistics courses dedicated to what's known as regression analysis, but because it doesn't appear linear, we're not going to get a value of r for this. But if we looked at different models to get a regression equation for this, it wouldn't give us a value of r because it's not necessarily going to be a linear model. It's going to give us a value of r squared, which we can still calculate it using the more traditional formula than the one that was presented in this section. So again, if it's not linear, it's not going to give us a value of r, which means how does it get the value of r squared? Well, there's a formula for that, which I'm not really going to get into in this video, because in all honesty, you'd probably want to let the technology calculate it for you. So even in Desmos, you can apply different kinds of equations. This is a linear one. You might want to do one that's maybe quadratic, like ax squared plus bx plus c, and it'll give you the value of r squared. Will not give you the value of r. It'll only give you a value of r here if it's a linear regression equation that you're entering in to Desmos, and that's pretty much universal for a lot of the statistical software packages that you may be using. So, all right, that about does it for this video.